This is the notes for objective number 1.7, translate among the forms of a linear function. We'll start with the most basic, the linear equation. So you're always going to have an x. That x is our independent variable. Or the input. You're also always going to have a y. That's your dependent variable. Or the output. In this case, y equals mx plus b. This is the slope-intercept form of an equation because b is the y-intercept. It's where the line crosses the y-axis. And m is the slope, which is rise over run. So y equals mx plus b is the most basic form of your equation. When we graph, we're moving from an equation to a graph. An equation to a graph. So translating the same information from an equation to a graph. To do that, when the equation is in slope-intercept form, take the y-intercept first, which in this case is always b. In this case, that's -3. So b equals -3. And you're going to plot that on the y-axis. So this is the y-axis here. And we're going to plot this on the y-axis right here. Next, you're going to take the slope and you're going to count up and over using the slope. In this case, the slope is 2. M equals 2. Which, if we have just a whole number, we want to put over 1. So 2 over 1. Remember, that's rise over run. So we're going to count up 2 and over 1. And we're going to put a new dot. Up 2 and over 1. Up 2 and over 1. And that is going to make our line. Then you're going to take your ruler, you're going to take or your straight edge, and you're going to plot the line through the points and put arrows on the end. And we'll do the next one. Here, again, find the y-intercept and plot. Our y-intercept is b equals 4 in this case. So we go up to 4 on the graph. And our slope here, m, is -3 over 2. Always assume that the negative just goes with the top number. So we go down 3 this time, 1, 2, 3, but we always go to the right 2, 1, 2. Down 3 to the right 2. Down 3 to the right 2. You need a minimum of 2 points to make a graph, but I always like to do more than 2 just so that I know that I make the line correctly. Draw your line, put your arrows. Example number 3 is slightly different because we do not have our line in slope-intercept form. In order to do that, we need to solve for y. 3y minus 2x equals 3. Remember that when we solve for y, we're trying to get y all by itself. First, we need to move this -2x to the other side, and you always have to do the opposite operation to move something to the other side. So plus 2x here, plus 2x to both sides. This cancels out, leaving us with 3y equals 2x plus 3, and then we divide by 3 on both sides, because that's the opposite of that multiplication. You get y equals 2 over 3x, 2 divided by 3x, and then 3 divided by 3 is plus 1. Now that it's in slope-intercept form, I go to 1 on the y-axis, because that's my y-intercept, and I go up 2 and over 1, 2, 3. Up 2 and over 1, 2, 3. And then I plot my line. Arrows and extending past the dots. Finding an equation from a graph. So write the equation of the line on the graph. It's best to do this in slope-intercept form, y equals mx plus b. First, find the y-intercept. That's where the line crosses the y-axis. That's right here at -1. You're always going to have the x, and you're always going to have that y. The only other piece of information we need is the m, or the slope. To find that, count from one point to the other. Up 1, 2, 3, and over 1, 2, 3, 4. Remember, that's rise over run. 3 over 4x minus 1. The same thing here. Start with y equals mx plus b. Find your b first, which in this case is 3. So plus 3. You always have your x, you always have your y, and then we need to find the slope. Count down 1, 2, and over 1, 2. So that's -2 over 2, and you do want to reduce that. So -2 divided by 2 is -1x plus 3. Lastly, we want to be able to translate from a series of points to an equation. So far we've done an equation to a graph, then a graph to an equation. Now these are points to an equation. First we need to find the slope between these 2 points, and that we use the slope formula. So m equals y2 minus y1 over x2 minus x1. This is x1, this is y1, x2, and y2. So that is -13 minus -1 over 6 minus 2. Well, 6 minus 2 is 4. -13 minus -1 becomes +1, which gives us -12. -12 divided by 4 is -3. Now we're going to use what's called the point-slope form of an equation. That is y minus y1 equals m times x minus x1. We know what m is. That's -3 because we found it using the slope formula. You're always going to have this x and you're always going to have that y. But this x and this y come from one of your points. It does not matter which one you use. I like to use the one with smaller numbers, so 2 and -1. We'll plug the -1 in for y1, so minus -1, and then 2 in for x1, minus 2. That is technically an equation, but I asked you to put it in slope-intercept form. So in order to do that, we need to solve for y. We're going to distribute here. So we get y minus -1 equals -3x plus 6. And then this becomes +1, so y plus 1 equals -3x plus 6. And then the last thing to do to solve for y is to subtract 1 from both sides. So y equals -3x plus 5. Same idea on the next one. We start with the slope formula, y2 minus y1 over x2 minus x1. We plug in our points, -6 minus 10 over -1 minus 3. So that's -16 over -4, which is +4. Then use our point slope form. Y minus y1 equals m times x minus x1. 4 is our m, so we plug that in. We always have that x. We always have that y. These numbers then come from one of our points. I think that 3 and 10 are easier to use because they're both positive. So x minus 3, because that's the x, and y minus 10, because that's the y. Now solve for y. Distribute. Y minus 10 equals 4x minus 12, and then add 10 to both sides. Y equals 4x minus 2.